Uh, Hello everyone. Good morning and welcome to the 10th Let's Talk Spatial event. So I'm glad to welcome you all, taking time on your Saturday morning coming here for this. Okay, so let me introduce what is Let's Talk Spatial and then we will go into the agenda for the today. So Let's Talk Spatial. I'm a co-organizer of it, and we have Amruth, who's there. He's a co-organizer, and we have two more organizers, Aman and Tiago. They are not here today. So we were just working in different companies, and we thought, why don't we have a platform for geospatial folks to come and interact? Then we on last year, July, we just said, okay, we'll do it. Let's try to do it, and then we met, and our first meeting had SatSure Analytics. Then from there, we were doing it for every month, and this is the 10th Let's Talk Spatial. We are going to be 1 year, so we are really happy marching forward to it. And we have our website here, letstalkspatial.in. We will post about the recent talks, any other updates from the Let's Talk Spatial. You can come and visit. Okay. So today, the theme is going to be. So for this 10th Let's Talk Spatial, the theme is going to be enabling continuous monitoring of Earth and GeoAI and edge computing. So it's the GeoAI. You would have heard this word of buzzing word AI. Even in the recent Google I/O Summit, you would have seen AI everywhere. So today we are going to see what is GeoAI and the edge computing. So I'll just read the definition what it is given in the Accenture website regarding edge computing. Edge computing is an emerging computing paradigm which refers to a range of networks and devices at or near the users. And for GeoAI, they have given transforming the architecture, engineering and construction industry with its ability to extract information from imagery which feeds into digital twin. So this is the basic introduction I gave. We have three experts from the domain who are going to explain what it is and give us insights about it. So the first speaker is going to be Parag Ramteke. He is going to talk about applications of remote sensing in fisheries. So let's welcome him. Okay, so Parag Ramteke is the product manager at Captain Fresh, specializing in geospatial technologies and bringing in wealth of experience in building innovative geospatial products across the industry verticals. He is known on driving location intelligence tech, enabling initiatives for ensuring sustainability and traceability in business processes. Okay.
So, hello everyone, my name is Parag Ramteke. Okay, so good morning everyone. My name is Parag Ramteke. I'm a product manager at Captain Fish, and today I'm going to talk about application of remote sensing in fisheries. Just a basic introduction about myself. So I'm an engineer by training. I graduated in agricultural and food engineering discipline from IIT Kharagpur. Thereafter I did my masters in operations research from ISI Kolkata. So I come from a background of core domain expertise in agriculture plus statistical interpretation of physical processes. That is what I have been working on in my past experiences in companies across business verticals, be it banking or agriculture, NBFC, or core banking in giving services to customers based on location intelligence technology. And in that spirit, I had joined Captain Fish because this is a very unique and niche space which pertains to ecology in general and the business surrounding it. So fisheries in particular, I will want to talk a bit about it. this session I'll cover fisheries landscape in India, the sustainability in fisheries, why is it necessary, particularly about sustainable development goals 12, 13 and 14, the challenges for scale and sustainability, and the practical applications of remote sensing for monitoring and managing the marine resources. At the end of the topic, or at the end of the talk, I will try to cover a few edge cases pertaining to remote sensing in fisheries, how we can conceptualize them and how we can see it in practice, how industry is using it. So, yeah, and to start with, just a basic introduction about Captain Fish. So, Captain Fish is a B2B technology platform which specializes in fastest harvest to retail story of seafood and fresh aquaculture food. What does that mean? This industry, fisheries, if you talk about it in particular, this is very receptive to shelf life of the product. For example, as soon as you harvest something, the shelf life counter clock ticking. So from the time of harvest to the time of packaging it, processing it, putting it to a retail supply chain, every step of the way is very critical. And this is where you will need to create digital twins for the physical process. So if you don't know about what digital twins are, it is basically a representation of physical process. It could be any process. It could be a business learning. It could be a standard operating practice that workers follow on a day-to-day basis. So first point of contact is digitizing all of these stakeholders at various anchors which form the supply chain of product getting transferred from one location to another. So essentially in supply chain there are two things. One is the money material movement. Money movement in one direction and material movement in one direction. This is where the processes have to optimize in order to come up with the optimal solutions for knowing what material is going where, who has ordered it, tracing the entire value chain. That is what is valuable in the industry today. So if you are on this premise, I want to take you through the fisheries landscape in India and what remote sensing aspect of technology Captain Fish as a company is trying to play. Okay, so when I talk about fisheries in India, just a business context, so this is the only sector which has given a double-digit growth rate annually since 2014-15 to till now. What does that mean? It means many things. It means that this is a primary factor for driving Indian economy. We talk about agriculture a lot, but this is a sunrise sector. That is, it is not in the limelight yet, but it is going to be in the limelight soon. The next big round of funding you'll see is coming in the sector. So, fisheries in India, if you talk about it, there are two aspects of it. One is marine side, second is aquaculture side. So marine side, when I say it is all hunting and gathering. Aqua side of things is all culture, that you farm something. For example, you do it in agriculture. So once you go to the marine side of things, it is all hunting and gathering. I will repeat this. It is very pertinent to understand what is hunting and gathering. So typically in here you don't know where the fish is going to be. There are a lot of operational challenges. Once you go inside the sea, there is no connectivity. The people who are engaged in this kind of employment, they usually don't have insurance. Once they go inside, they don't know whether they will come back or not. The aquaculture side of things. So this double-digit growth rate part of story, I would want to connect with aquaculture. So what has happened in the past 100 odd years is, we have gone from traditional fisheries to commercial scale fisheries. What does that mean? So earlier the boats were very small, alright. So people used to go for fishing only for a day. They will cover a distance of 20 kilometers and come back. The time required for fishing is like optimized for one day. The catch quantity was limited. So there was a replenishment rate in the ocean ecosystem. But what happened in the last 100 odd years is there has been a development of commercial aspect of fisheries. Now, there are large boats which are able to put a crew of 20 to 30 people. It is able to stay in the ocean for about 40 odd days, 50 odd days. They continuously hunt for fishes and then they take the material out of the ocean in bulk. So when I say bulk, it is like in the order of millions of tons daily. So that leaves fish resource depletion in the oceans. Okay, so this is the context of the fisheries in general and how they have evolved. I'll want to throw some numbers around what the current scenario in India is. So if you look at it, India's got a coastline of 8,000 odd kilometers with all the 9 coastal states adding value to the marine catch in particular. So earlier the double-digit growth story I will come back to. So that double-digit growth story is mainly driven by aquaculture, not the marine, because since we have overexploited the resources in large amount for a major period of the past century, the fish productivity has stagnated. So one statistic in mind if you want to look at, there is a particular potential for every country to reach from its economic sources of fisheries. For example, the economic sources of fisheries for India is exclusive economic zones. It's a 200 nautical mile area surrounding the coastal areas of India, where India can legally fish. So if you consider the marine potential of that particular economic zone, it is coming out to be 5.31 million metric tons, out of which we have already exhausted 3.71 million metric tons. So year on year, our growth in terms of extracting fish resources from marine side has got stagnated. But on the aquaculture side, since we are doing farming, we can convert agricultural land which are more salinity driven, or let's say which are not used, we can convert them into aquaculture ponds and then use it for increasing the land area for which comes under aquaculture, and thus boost production and productivity. So majority of this growth story of past 10 years has come from aquaculture. So still marine in current context gives India export value of $7.1 billion. So this is a very big market opportunity and it is bound to grow because India's fisheries is still not commercialized. It is a mix of traditional and commercialized fisheries. So in particular when I talk about this, I'll also first want to take you through the inland fishery statistics. So inland farming is being done across the country. And across the country you'll find fallow land, degraded land. So there is an extreme potential for reaching this current 16 million metric ton to 22 million metric tons. So that is about the fisheries landscape in India. Now let me talk about the sustainability in fisheries, particularly where the remote sensing can come and play a part around sustainable development goals number 12, 13 and 14. So can anybody of you tell me what is SDG 12? If you know. So 12 talks about responsible consumption. So just now I talked about marine aspect of things, how overexploitation has resulted in depletion of fish resources. So it becomes very pertinent for organizations to follow sustainable practices. What does sustainability mean? Sustainability means that over the period your fish stocks should not deplete. That is, the rate of extraction should not overgrow the rate of depletion or the rate of production, sorry. So when I talk about it, Captain Fish as an entity is heavily invested in ensuring that we sustain over a long time. So what all sourcing that we do from at the time of harvest to the retail, we try to maintain an aspect of traceability in every outcome of procurement, like be it harvest, be it boat going to the ocean, tracking its time when it reaches the fishing shoal, how much time it is spending for fish catch, how much fuel is it consuming in order to catch the fish and returning back. So all of this, if it is digitized and marked with a metric which corresponds with depleting fishing stock, it can be understood that certain practices are sustainable so that the fish stock are not depleting. That is what our endeavor in Sustainable Development Goal number 12 is. That we want to promote responsible consumption, where we give information about traceability, allow the end consumer the option to choose whether to buy a product or not based on the value where it has come from. So that value addition by virtue of data gathering and assembling and organizing and putting a tag onto the product, that will give you a sense of commitment in order to realize this goal. Goal number 13 talks about climate action. Now again I'll come back to this over-exploitation of fisheries. Why it is linked with climate action. So when you deplete the fish resources, what you're doing is you're taking out the biomass out of the ocean. So ocean is sort of a ecosystem. Ecosystem has got multiple stakeholders. Every stakeholder has got a role to play. Every stakeholder has got a role to play. So what does that mean? That if you take out any of the ecosystem stakeholder within the point or out of the point where it is not able to replenish, what you are doing is you are allowing the other set of the ecosystem stakeholder to overgrow in its population. When it does, it ends up consuming the level below it and becomes a threat for its own population. Got it? And as a result of which, all the geophysical phenomena that happens with livestock, for example, let's say they spawn, they excrete, they mate, there are many aspects of it which releases chemicals in ocean, which are very important for sustaining coral reefs, which are very important for sustaining helpful algal blooms. So all of these phenomena actually they help in managing the climate change aspect of the world. For example, I'll give you a case in point. For example, if you kill the whales, that happens at a large scale in, let's say, Japan and China. There is a commercial whaling industry which ends up killing whales. The whales, they end up stimulating phytoplankton growth. So phytoplankton is something like a small microorganism which has chlorophyll in it. It acts as a primary producer in the ocean. So if its stock depletes, you'll find that the amount of oxygen which these phytoplankton generate in order to sustain the entire ecosystem, that depletes. If the oxygen depletes, the capability of ocean to degrade certain things, that depletes. If that depletes, the amount of carbon dioxide that ocean usually sinks inside it, that depletes. As a result of which, the temperature increases. So how often in terms of climate change do we talk about overfishing as a potential cause? No. This is a very insightful fact about why we should be focusing on climate change from the perspective of fisheries. So as a company, we are very much invested in, first of all, bringing to realize that this domain which we don't see in our day-to-day lives because we typically live on land, but the coastal communities, the traditional fishermen who have been part of this journey for time immemorial, have been seeing the changes firsthand. And in the past 100 years, their livelihoods is threatened. One is because of commercial fishing, because commercial fishing exploits a lot of material from the oceans, and it leaves very little to no room for them to go and fish. So I talked to a fisherman who is a 7th generation fisherman when he talked about his story. So his grandfathers and parents, when they used to go to fish, they used to travel about 1 or 2 kilometers in the ocean. And then they used to catch bountiful of fresh catch. But same scenario now, he has to travel 20 kilometers deep inside because the fish source has already depleted. And at this rate it continues. In 20 years this industry is done. And that is the shelf life of this industry. And that is the shelf life of all of the coastal communities living with it. Because apart from commercial fishing, when we talk about traditional fishermen, their livelihood is dependent on that. That is the only source of thing that they know. For example, you and I may earn our livelihoods. Let's say some pandemic comes, we can find different sources of employment because of the training that we had. But for them, this knowledge has been passed from generation to generation. It's very critical for them to salvage their source of livelihood. So that is the context of SDG number 3. SDG number 4 talks about life below water. So when I talk about life below water, I will want to shift the focus from marine to aquaculture. So as I told you, the major part of the growth story in terms of that double-digit growth rate in fisheries sector has come from aquaculture. So aquaculture is sort of something that you farm, you don't hunt and gather. In hunting and gathering, you can't play with the ecosystem. It is all like ocean, wild thing. They are all wild catches. You can't interfere with what goes inside them. But in aquaculture, you can put n number of things. You can put fish meal, you can put antibiotics, you can put n number of things which are harmful, not just for fish but for you as a consumer as well. So life below water is very essential, because what happens is, like, I'll just take a minute to explain this. So any kind of fishing which involves scale has to do with standard operating practices which help you achieve that scale. Now these operating practices, since it is built for scale, it won't forbear sustainability. For example, there is set rate of doing everything. If your average body weight of shrimp is 12 grams per piece, you will end up putting 5 kg of feed at random. Same in agriculture. If you take a context of agriculture, the farmer mindlessly, without doing soil test or water test, he ends up putting fertilizers across the field without knowing what is the variable fertilizer rate or where it should have actually put. So this is a practical challenge in this industry. And when the water, the pond water, at the end of the cycle, when it is drained out, it mixes with the water stream. It pollutes that water stream. It forms harmful algal blooms. It kills the aquatic life. That water stream then runs into ocean. In the ocean, again it forms algal bloom. So the fishes which were used to be around coastal areas, now they are far away because of this harmful algal blooms. So this is how these goals are interconnected, and there's a need particularly for this industry as well as government and organizations in general to leverage technology in order to monitor and manage these resources in a sustainable manner. So this is the entire premise on which my talk has been. I hope I conveyed some aspect of it in order to understand why remote sensing technology is necessary and why there is a market behind it. For example, in this industry it is very difficult to find space applications in real life world. So you need to have knowledge of these both aspects of businesses as well as technology in order to bridge a common ground, drive everyone to a common vision, to take them forward a few steps in the right direction. Okay. So now let me talk about the challenges for scale and sustainability. I told you this digital growth, or sorry, it's a double-digit growth of 10% annually is fueled by demand. The demand for fish consumption or seafood consumption has not gone down, and it will not go down. So what has this resulted in? This has resulted in, let's say, endless rat race in order to extract whatever is available, whatever is moving in the ocean. So you want to catch tuna, you put up fishing nets. It doesn't matter to you what that fishing net is catching. You put harmful fishing nets that catch turtles, that catch sharks, those hooks, they sort of they attach with the gills. So when the fish is moving, in order to get the bait, the fish is moving in a horizontal direction and the bait is like scorching its gills. So it's so painful for the fish that they don't care. Because if we fish by hook net or gill net, so the exertion for fish is like highest. And the value which the industry puts on wild catch is based on its quality. The quality, I mean that, let's say, if the fish is not in stress, for example, if you catch it just by its mouth, it is not damaging its entire body. Right, so there will be no condition of stress for the fish in general. So if the fish is in stress, it will lose its shells. So the fish has got thick skin. So if it is struggling a lot, that thick skin will pulp. If it pulps, the average shelf life for it, even after icing, reduces from 14 days to 7 days. When it reaches the marine shores, the supply chain guy who is basically a supplier, who ends up taking a look at that fish quality, gives a lesser rate. But he still sells that fish under the grab of good quality fish to a retailer sitting in Pune or Mumbai or some places. So this industry typically thrives on misinformation. not just misinformation, hidden information, that you hide the source of truth. You play on the sentiment that, okay, I am in need because I have demand. You fulfill my demand. And in the shortest time possible. So the scale and sustainability, this sort of, there is a dichotomy. So they can't go hand in hand. I want to just talk about this from perspective of remote sensing. So we as a company are invested in scale as well as sustainability. So what all suppliers we deal with in terms of procuring the seafood, we basically end up asking for traceable information. So what I mean by that? So there is a lot of problem around this IUU, the catch which is illegal, unreported and unregulated. What does that mean? Illegal means every country has got an exclusive economic zone. Sorry, by the way, please remind me if I am exceeding my time. Sure. So, illegal. Illegal talks about like fishing outside your exclusive economic zones. You'll find boats out of Kochi fishing there in Madagascar. So these guys without insurance on an NG boat with a generator on, with a crew of 10 to 12 people, putting up their entire year's life saving into financing that boat trip, goes to Madagascar, stays over there for 20 to 40 days, catch in abundance 40 tons of fish, come back where they are not legally allowed to travel by Indian government. Because this all talks about sustainability, and the fish you might be eating is coming from that region. So nobody talks about this. They want their fish at any cost, any process possible. So this in particular, the problem of illegal, unreported and unregulated fishing, we are trying to solve using remote sensing. So every boat that goes inside the ocean is fitted with a transponder called as AIS transponder. Do any of you know about this? So this transponder is basically VHF based frequency transponder, which tells you the boat position, its speeds, its direction, its acceleration for the other vessel to know. In movies you might have seen that a whole navigation chart would be there and you would be seeing dots and its movement in a particular direction. That is AIS system. So this AIS transponder basically transponds not just for next boat but also to the satellite. Okay, so that is how we can gather all the boats who are having this AIS transponder and their fishing locations and their boat routes. So if a particular fishing boat is there, how do you differentiate between a fishing boat and a container boat? The container boat is tending to travel in a straight line, but a fishing boat, after traveling into a straight line till a point that they reach a particular fishing shore where the fishes aggregate, so they will end up putting up the baits. So when they end up putting up the baits are of different types. It can be bottom trawling, it can be gill netting, it can be putting a ring around it. So depending on the bait type, they will take the course of the ship. They will move in a zigzag pattern. And then after some time, after that they have put the bait, they will wait for the fishes to aggregate. Once they have aggregated, then they will close the bait by either pursing the seam. That is the proper gear name, purse seam. So purse is like purse, zip a purse. So you put the purse around the fishes and then zip it. So there is another fishing method. If you just look at the second figure, put 2-3 examples of gears, fishing gears. So one is trawling. So in trawling, what happens is you have got two boats in parallel. Behind it there is a net, a huge net with a heavy weight, which is at the bottom of the ocean, and the boats travel in straight line, or they diverge like this. So once they diverge like this, what happens is that net drags all the catch up. So it will divulge the underground, whatever aquatic life is there. It will divulge the coral reefs, it will divulge the underground plants which are responsible for giving oxygen. They will take away everything, every part of marine life present in the ocean. So this is the most harmful sort of way in which fishing is done. So you can see the boat routes. So the boat routes typically talk about, like, you can see this, the lines they are following. They are diverging like this and then pursuing it. Similarly, if you talk about long line is a fishing gear, you can see it at the bottom. This is long line. So you put fishing baits in a long line, like 50 miles, 100 miles, and then allow you, you allow some time for fishes to get stuck in, and then you follow a particular pattern. So with the help of these patterns, these boats are following, you can identify what type of boat that was, what type of fishing it was it sustainable, how much time it was in ocean, and if you are catching from that boat, are you adding value to your end consumer? Who is interested in sustainability? Understood? So another unregulated and illegal and unreported example is marine parks, marine conservation parks. So just like we have wildlife protection areas in terms of wildlife sanctuaries, national parks on the terrestrial ecosystem, similarly we have marine parks, marine conservation parks. So what happens is many of the times we have observed that even in India, so many of the Chinese fishing vessels will enter Indian coastal waters because it is 8,000 kilometers long. And since it is 8,000 kilometers long, there is very limited means to monitor it, manage it. So what they will do is they will just stop by the boundary of the protected area and they will stay over there. It means that they have put a net around. And this has been happening at a scale. Our Indian government, by virtue of its differentiated state policies for each state government, has not come up with a unified command to order and instruct the coastal guards in order to manage and monitor this unregulated fishing. So every state has got different regulations for fishing. Some states will allow for high seas fishing, some states will restrict their boats to limited in traditional waters. So and a lot of this unsustainability for commercial scale fishing is being driven by subsidies. So you subsidize for their fuel, you subsidize for their gear, you subsidize for their electricity cost, icing cost. So all of these subsidies have resulted in aggravation of overexploitation or depletion in a large scale manner. If at this point we stop the subsidies, the overexploitation can be reversed, because then the fishing becomes economically less possible. Like it is not economically fruitful. Because of the subsidized fuel, you are able to spend 20 days, 30 days. A typical cost of fuel consumption for one day is about 2,000 liters. So if you add it up to 40 days or something, you're almost consuming like what? God knows how, 80,000 liters of fuel. And that is just for one fishing trip. You do 3 to 4 fishing trips in one cycle. That is of 3 months, 4 months. Okay, now coming back to remote sensing solutions for monitoring and management of potential fishing zones. So there is a concept, something called as potential fishing zones. We as a company have tried to see this problem and come up with solutions product-wise in order to benefit the end users, which are like, let's say, the fishermen, to maximize their catch quantity. For example, one metric of so we always talk about measuring sustainability, right? So how do we do it? We have to do it in terms of metric. So one of the metric that we can talk about in terms of building sustainability is catch per unit effort. That for every unit effort that you are putting in terms of fuel, ice, labor, manpower, how much of catch you are getting, and is that catch increasing over a period of time? So that metric is being fulfilled by something called as potential fishing zones. So potential fishing zones are sort of those areas in ocean where the fishes aggregate. Now the fishes follow ecological food chain, in which there is a primary producer called as phytoplankton. It does photosynthesis. So after the photosynthesis, smaller fish come to eat that primary producers. To eat that smaller fish, bigger fish come. To eat that bigger fish, more bigger fish come. So it is a fishing show. It becomes an ecosystem. So those primary producers, they tend to have chlorophyll. Once they have chlorophyll, they do photosynthesis and they change the color of the water from blue to bluish green. And that can be picked up from satellites. That is how potential fishing zones are alive in terms of remote sensing. So remote sensing capabilities for Indian government comes with InGARSS, an organization called as InGARSS. InGARSS is Indian National Center for Ocean Information Services. So what that organization does is basically it has got a satellite called as OceanSat-2. It takes it covers both the coastal coasts of India, and on a daily basis it gives advisory in terms of sea surface temperature, chlorophyll pattern, high wind speed patterns, sea current directions, wind speed directions. So all of these along with the bathymetry is used to generate, bathymetry is something like depth in the oceans. So that is also, by the way, very important for knowing where to do fisheries. For example, if the depth of the ocean is very shallow and you end up putting a gear which is like very deep, you'll end up damaging it, and that costs more. So your economic viability of that fishing trip itself is like lost. So it is like, it is definitely not worth going over there and not knowing what the depth is. So coming back to InGARSS, so this is what they publish. So you can see this is for yesterday. This talks about the sea surface current. So on the eastern coast, particularly around this Nagapattinam, Visakhapatnam border, you will find higher sea surface currents. It is not suitable for boats to go inside. And there is a fishing ban for 2 months basically to allow fishes to repopulate. That is the extent of overfishing that we have done. So Government of India formally introduces a 2-month ban where no fishing is allowed. So InGARSS, by the virtue of this data at scale, is able to give you something like this. So the blue lines will talk about the potential fishing zones. These are the exact locations where you go and catch the fish. So these locations have been captured how? Again, there are satellites. Satellite gives maps of temperature, chlorophyll. You have particular ranges of temperature and chlorophyll with fish association. That fish, for example, a typical example I give is sardines in Mediterranean waters are found to be in a temperature range between 22.5 degrees Celsius to 28.5 degrees Celsius, and in a chlorophyll range of 0.3 to 0.5 milligram per meter cube. So in these ranges, you can isolate the pixels in the heat maps which are intersecting with the potential fishing zone of sardine. And then you come up with these lines which you direct to fishermen that you go and directly hit these lines, you will find fishes. So that you can reduce your search time, you can reduce your fuel consumption, you can go for a higher catch per unit effort, and you can be sustainable as well as economical. So this is one aspect of product that we have driven by FishDrone. So FishDrone is a flagship product of Captain Fish that we have built. It is built for B2B seafood trade. And one aspect of it covers the community aspect, which gives fishermen a source to go and hunt in a sustainable manner. Okay.
10 minutes.
10 minutes. So this FishDrone has been adopted at scale for past 1 year, and all the analytics that we get out of it, I want to present you. So fishermen use this potential fishing zone as a feature. They set their boat route to reach a particular fishing point. They fish over there with the help of their local traditional knowledge. For example, I want to tell you, if you fish in the middle of the line, in the green star mark areas, you'll get maximum catch. If you veer away on the edges, you will get minimum catch. If you, on the second image, if you see, on the yellow marking, so that is the direction of the wind speed. So this forecasts are available for 1 day in advance. So once you go inside the water, there is no connectivity. So this forecast can be dynamic. So you have to rely on the forecast of weather. So based on the surface weather parameters, you will see where this fishing shoal is moving. This is very helpful for them. Imagine a scenario where you are without internet, all by yourself, wanting to reach a destination. All you have is your 6 senses, your traditional expertise, and a girth and determination to find fish. you're lost at sea typically, and your entire livelihood depends on it, whether that fishing trip is successful or not. Because if it is not successful, if you are going empty-handed, you won't be able to raise enough capital to go for the next trip. Then you will have to get to a supplier, a person higher up in the valuation, ask money from him. He will in return ask for the first rate of sell of that material that you catch. And you will be in forever debt cycle to that supplier. That is how this industry works. And this is why this is important to enable and empower these fishing communities in order to sort of survive themselves in this sort of very dynamic landscape. Okay, so as I told you, like this is a FishGram analytics part. So once we, so what we are doing in FishGram is we are asking people who are using this feature to log their catches. So if they log their catches and give us our material, their material, we end up paying a premium for it. For example, if the fish is selling at 220 rupees per kg, we'll give 225 rupees per kg because we can make that margin from the end consumer who believes in this sort of data. If you have sustainable data which is traceable, which is driven by a metric for sustainability, for example, catch per unit effort, which can be built over a time to prove a case that the fishing practices in a particular area are sustainable for a particular species, you have got a very good case study and a chance of creating an example for replicating it elsewhere in the world. So as a company, our vision is aligned in that direction. So we ask our fishermen to supply us with their catch data, and this is one such example of that catch data. So all the fishing points in the first map that you see are all the tuna catches that you have found in the western coast and the eastern coast. So you see the concentration of the tuna catches. It is around Karnataka, Kerala, somewhere around Gujarat coast. And these catches are like over a period of time. So over a period of time, the tuna migration also happens. There are a lot of opportunities with the help of this data to explore where all the tuna is migrating, what all could be good potential fishing zones, what all fish improvement programs we can bring in at certain coasts or certain ports where the fishes land. How can we certify a particular location as sustainable? How can we milk value out of it, create a product out of it, give it to end consumer with a story of traceability? So look at it, we have even classified it with the help of gear tech. So what kind of gear they're using, whether sustainability metrics, where we are. So all of this data is very interesting and relevant for marine management in particular. So we want to enter into fish improvement programs at various coasts where we procure from, and we want to certify our standard operating procedures into a tag. For example, let's say sustainably caught via Captain Fish. We embed it into a product journey, or let's say we embed it into a SOP, which will call for a product line for every material that gets caught and processed in a particular factory, and sitting at a shelf life sitting at a shelf somewhere in Europe with that label of sustainably caught and driving a value out of it. So that is what our endeavor is. So eventually we want to build something like this, green zones, red zones for sustainable fishing based on these catch location as well as other data which is coming from inquiries as well as sea surface temperature, migration patterns, whatnot. Shifting back to aquaculture, as I told you, like marine-wise, if you talk about it, this IUU plays a lot of part in sustainability in aquaculture as well. So when I talk about illegal catches, so there are a lot of bycatches. For example, if you want to catch tuna, along with it sardines are caught, or some low-value fish is caught. So they don't release it in the ocean. They take it out because it is already dead, and then they bring it out and give it to fish meal companies. For example, all of this cat food, dog food, fish food, all of these companies use this dead fishes which are caught illegally, which are caught as bycatch. They sort of process it, convert it into fish meal, extract oil out of it. That is what they call as omega-3 fatty acid. So basically that omega-3 fatty acid is nothing but acid or oil generated by algae, which has been consumed by the fish. Fish itself doesn't contain omega-3 fatty acid. It is that algae. And by virtue of taking out all of this fish, you are eventually disrupting this algal balance. You are killing algae altogether, and then expecting fish to give you oil. All the products about aquaculture sustainability, which talks about fish meal, that is, there are small pellets. For example, in agriculture, you give fertilizers, seeds, right? So in the similar context in aquaculture, you give these pellets called as fish food or fish meals. So this fish meals, okay, the last slide. So it is generated by the illegal caught material, and this is again being fed into aquaculture. So most of the aquaculture story, how much feed that you put in the pond is actually really relevant, because most of the cost of aquaculture is dependent on the feed cost. And in order to market sustainability, you have to be very careful about how you monitor it. So this is where remote sensing can come and play a part. So we have come up with a boundary detection algorithm which can talk about area estimation, yield prediction, biomass estimation, and it can direct in what magnitude the feed has to be put, so that you are sustainably creating a biomass, and you are on a long term not polluting the environment in general. So mostly this is it for my talk. This is my last slide anyway. So hopefully I conveyed you the nuances in this industry and how remote sensing is helpful in order to manage and monitor the marine resources in a sustainable way. Thank you.
Any questions? You can take 2 questions. Excellent.
What prevents what prevents commercial entities to use these practices, whatever you mentioned?
So one of the things that is driving this commercial enterprise is demand. So demand is not going to go away anytime soon. So until the time they exhaust all the resources, they will stop.
No, what I meant was your product, right? Fish drop. So that tells where the fishes are. So that will tell commercial entities the same way.
No.
Right?
So we are targeting it in a closed community manner. We are enabling, see, commercial fishes, they don't care for quality. They'll put this harmful gears which will stress the fish. We thrive on quality. So once you're doing a quality harvest, you have to be very time intensive. You have to stay longer, you have to use the right fishing gears, you have to wait for the fish to come into that gear. You have to handle it properly, you have to ice it within 1 hour. You have to communicate to the buyer that I caught something, right? So all of these things we are trying to run with a closed program, with a set of community members who are aligned with our vision. Because see, in this, catch is plenty. Since India's fisheries is not yet commercialized, you can still find fishes. So whatever people are engaged in value-driven fishing, we can enable them, empower them, incentivize them in order to fish better. That is what the fish farm is intended to do.
So one more question. How did you validate that your customers are actually interested in the sustainable? Because most of these, like whenever the company is concerned about SDGs, right? So
people won't be concerned about it. They don't even know what SDGs are. As a company, it is our initiative to put weight on behind SDGs, because we are operational all over the globe. Our major market comes from US and EU. That market values traceability. That market values sustainability. So in order to build it as part of the SOPs, standard operating procedures, where we take the material out of the sea and put it to a retail supply chain, that journey has to be digitized first, mapped first. That is where the investment comes from.
I mean, from a business point of view, because unless someone is
we can talk about it, I think. You know what, you're satisfied with my answer, but we can certainly talk about it.
Any more questions? We will have it in a networking session. Thank you for this valuable presentation. It was very
Actually, you seeded a thought with us, like whenever next time we are going to see a fish in our plate, we will see whether it is sustainably caught fish or not. So yeah, okay. So we will take 10 minutes to like introduce ourselves, and then we will go for the next presentation. Before that, the restrooms are here, and if you want water, you can go and have. That's in the right side. Maybe we can start from the last. Just say your name, from where you are, what you are doing. Raghavendra, can you start?
Okay, I'll start and then we'll go from there. Hi everybody, my name is Amruth. Kiran. I'm one of the co-organizers for Spatial. I'm a senior researcher at faculty at the Institute for Human Sciences, SatSure. My work is mostly in big data, model visualization, modern GIS solutions, model web, lot of survey, data and data science. Lot of GIS, wherever it's GIS or remote sensing, computer science, I hope I'm handling there, practical or whatever I can. But yeah, so most of my time goes in teaching, but a little bit of hobby development stuff also.
Hello everyone, my name is Goutam. So I work as a data scientist at Capital First. So where I'm exploring the potential of remote sensing data.
Namaskara, hi everyone. I'm Raghavendra SP. I'm pursuing Masters in Geoinformatics at Karnataka State Remote Sensing Application Center. My area of domain is bizarre data and crop classification and search. Hello everyone, I am Kiran. I am a PhD scholar from Naik of Technology, Karnataka. My area of interest is application of remote sensing in GeoAI, agriculture, water consumption, and
Hi, my name is Dilshad. I was working with Bengaluru data integration in person and now actually I'm looking for another job. I work with translation. Thank you.
Hi, my name is Sasthi. I'm working in sensor design automation. I work with computer vision and chatbots.
Hi, my name is Vatsal. I work as a data scientist at PTP. We mostly work on using data science and optimization for manufacturing problems. I joined CHP and had a notice in efficiency engineering and solving problems on the financial sciences.
Hi, my name is Ayushi. I am a SatSure. I'm going to explore more into
Hi, I'm Naik. I'm a data scientist at Kiran. I work for the computer vision team.
Hi everyone, my name is Kiran and I have just joined Spatial as a remote assistant.
Hi everyone, my name is Abhi. I'm the project manager for Goutam. It's a new space subsidiary of New Space Research and Technology. It's an aerospace and defense company. I just was introduced to the world of space and new space. Curious to know what it offers. Here to talk about it and thank you for this.
Hi everyone, myself Vishesh and I am a backend developer and I work for Goutam. And why I'm here is I want to work with, I was working on some problem related to traveling. So I want to learn more about how to handle this data because they are very new.
Hi, I'm Arya Pratap Product Manager in Reliance Geo. The current domain is not development related, but I have a education and interest history in the GIS and professional regions.
Hi everyone, I'm Vatsal. I'm also from Reliance Geo. I work in the advertisement sector. I handle user information and everything that is related to location and I work on visualization also. That's pretty good.
Hello everyone, my name is Vinny. I'm working as senior analyst at Avian Global Services. 2 months back I completed my master's in environmental engineering from IIT Madras. And I feel there's a lot of potential to build products out of satellite data for environmental management. So that is the reason I'm here.
Yeah. Hi guys, I'm Sai Prakash. I work in SatSure Analytics. So I work on the certificate which will analyze the farm to get the loans from banks and all. So we'll analyze the soil moisture, how it is.
I'm Ranjit. I'm currently pursuing my master's in GeoAI and looking at presently done in remote computations.
Myself, Rupesh Kumar. At present, I am pursuing MS in geoinformatics. Now, I am working as a project intern in the case study organization.
I'm pursuing MS in geoinformatics at Arya University. Currently, I am working in project intern in case study.
Hi, I'm Parag, and I'm a Naik analyst in creative production motivation, English processing projects.
Hi everyone, myself Brahma. I am pursuing MSc JS. Presently, project intern in RS in I am Kiran. I am working in a startup in Bengaluru. It's called GeoAI. And I have been working as a machine learning Hi,
Can you just say that?
I'm also working with GeoAI as well as scientist in data science. I did my doctorate in SAR and micro remote sensing, and I've been working in the for the last 7 years. And at AI, I work on different applications.
Hi everyone, myself Naik. I also work as a staff data scientist at AI. Majorly I work in the computer vision domain, and I also work on disaster damage assessment as well.
Hi everyone, I'm Gandhi. I work at WRI, Vatsal Institute as data analyst.
Hi, I'm Rupesh. I'm working with Spatial at GeoAI. From NIT. Currently I'm an intern at
Hi everyone, I'm Rupesh. I'm a final year PhD student at Ramya, and I was an intern at SatSure.
Hi, I'm Rajal. I work at SatSure. I'm a geospatial software developer. I work on data warehouse for backend the data and raster data. And my day-to-day job is web development and rasterizing.
Hi everyone, my name is Keshav. I'm from Texas Institute. So my interest is in general space-based hardware, so products and systems.
Hey, hi, this is Vishesh. I'm the CTO at SkyServe.
Hello everyone, I am Vatsal. I am working in Meetup. So I am basically interested in computer vision and AI part.
Hi everyone, I'm Anusha. Professionally, I'm a business analyst for a startup, but with my personal interest, I also pursue. I'm in a restaurant owner in Bangalore for consultant.
Hi, this is Arya Pratap Singh, data scientist from Goutam. Previously worked at ISRO and PSA and
Hi, this is Arya Pratap Singh. I'm working with data scientists and also
This one was done. Okay, let me complete my introduction. So I am Santhosh, working as a data scientist in Analytics. So it's a climate tech company. Mostly I'm focusing on carbon markets. Yeah, thanks for this introduction. If anyone likes another profile, you can interact during the network section and make a new connection. Okay, now I will take a moment to introduce Let's Talk Spatial website. In this website, if you just go down, there is a section called Register here. So these events, we want the community to come forward and someone from the community to come forward and be a speaker for us. So last time during the 9th Let's Talk Spatial event, Goutam was kind enough to come and say, yeah, next time come and host us the event in our office. So if you are okay to host us, do let us know. We are always looking for office to host this event. So I would like to invite Goutam to introduce about SkyServe.
Hey everyone, my name is Goutam. I'm working as a part of Founders Office in SkyServe. Thank you all for turning up here on a Saturday morning, that was so early. I would like to tell you a bit about what we do at SkyServe. So SkyServe is basically an edge computing platform. Now we enable geospatial applications, GeoAI models to be run onboard Earth observation satellites itself. So we partner with satellite operators who are into Earth observation, and we make our hardware sit on their systems, sit on board the satellites, and we enable other geospatial developers, geospatial companies who have these models, which basically are into continuous monitoring of Earth, to basically upload these models on board and generate insight directly from the space. So now with this we are trying to reduce the whole data footprint of Earth observation and make things more efficient, both on the satellite operator as well as the developer end. So yeah, that is a brief about what we do at SkyServe. So in the last speaker, who is from SkyServe, Rupesh, will be telling you more about what we have today. So we are sort of doing an official launch of our first commercial product, and we'll be talking about what you can do with it, and more about that would be coming as we go. And also Arya would be talking about how his models are basically running on such kind of a system and everything around it. So I hope all of you have grabbed your pen, paper, notes, everything. So we have something exciting coming up. So I hope all of you are taking notes. So we want all of you to just grab all the knowledge that you are gaining from all of these sessions, and maybe just share your learnings on your social media platforms, maybe on LinkedIn or Twitter or anywhere. So we have some exciting surprises for people who actually share their learnings from the event on their social media by tagging both Let's Talk Spatial as well as SkyServe. So do tag us. Tag Let's Talk Spatial, tag SkyServe on social media and share your learnings. And if you find that any one of those are really amazing, we would be definitely sending you some surprise goodies and some surprise gifts. So yeah, I hope all of you just are very keen about the upcoming speakers, and also whatever Parag spoke, I'm sure you might have had your eyes and ears open around that too. So do share your learnings on your socials and tag us. So yeah, that's about it. Thank you guys. I would like it.
I'll over to Santhosh.
Thank you. Let me take a moment to introduce our Slack group. So in our website, letstalk.spatial.in, there's a section for Slack group. If you are interested in joining this community, do come. So we have channels like help, jobs and internships. So if you want, you're stuck at something and you want to ask, it's like a Stack Overflow for geospatial people. So if someone will answer, you can get help. So you can come and join here. Okay, now let's invite our next speaker, Arya Pratap Singh. So he is going to talk about edge computing, the future of space-based computations. So Mr. Arya Pratap Singh, currently working as an edge computing scientist at Kalidio EO. He is a believer that sentimental AI can solve space-based problems in much better way, where his journey heads towards. He has contributed towards the various space missions, including Chandra into Venus Express and MRO, etc. His work has been presented in NASA Johnson Space Center, PRL, IRS. He was awarded as the best paper presentation by PRL ISRO for his Venus Volcanis through the Venus Express missions, ESA, which made him as an young scientist. Till days he received the prestigious award. Let's invite him.
I hope I'm audible, right? Yeah, thank you for the wonderful introduction, Santhosh. Well, to begin with, thank you everyone, thank you SkyServe for inviting me. So, today we'll be talking about edge computing, what exactly it is, and how it can change the way you look through satellites, how you look through the data that comes from satellite. To begin with, I'll tell you what the radio is.
Screen is not visible.
Yeah, sure. This is complicated.
Take the mic as
I hope this is good. Cool. So, Galidio is a SatSure company. We basically have our planned mission named InGARSS. We'll be launching it in 2025. It's a fleet of 4 satellites, and all those 4 satellites are going to give you 1 meter resolution on ground. That means you can see 1 meter of object from space clearly. All of the satellites will be equipped with edge computers end-to-end, which I'll be talking about. Going towards the topic, edge computing, the future of space-based computations. Pretty fascinating for me. I think it will be for you too. Let's talk about the history of satellites. Initially, we had something called air balloons. So this came out of curiosity. People, experimentalists like us, thought that let's see what space looks from certain height. Space means the ground here, not the actual space. So they wanted to see what ground looks from a certain height. No remote sensing, no computations, no analysis, nothing. Once they observed, they figured out that we could actually capture lots of information, very large area from that particular sense. Hence triggered the curiosity to see things from space. After that, we sent rockets to certain heights, few meters, then kilometers. We saw how signals traveled from those rockets and how did they receive to us, what information can we get from them. Further, we launched Sputnik 1. That was the first satellite, man-made satellite that we launched. Can anyone tell me what was the main reason for launching Sputnik 1?
Space race.
Yes, space race, but why? Why space race?
USA or USSR.
Kind of, yes. Cold War, exactly. So, when these Soviets, Russians, Americans, when they were done dropping bombs from certain altitude, they wanted to go even further. They wanted to drop nukes from space. That was the idea for launching satellites. They wanted continuous surveillance. Also, when KGB, the Soviet intelligence agency, and we also have CIA in the US, when they were done doing their experimentations on the country, they were exhausted seeing how can we extract information in our enemies, of course. So they wanted to see how can we leverage it. Further, they launched the satellites from their missions, and hence the space race for sure. From there, we came to Earth observations. We can do everything and anything you can imagine from space. In fact, we have the highest resolution satellite in India itself, named Cartosat 3, which gives you a resolution of 15 centimeters when upsampled. So imagine a 15 centimeter scale kept here. You can see it from space, how crazy it is. Now, let's see how this transmission journey used to happen. Why are we moving towards edge? What's moving us forward? Why should we go for edge? Initially in Sputnik 1, it was a 10-second beep, 2-second beep that used to come every 10 seconds. So that made us comfortable that yes, we can communicate through space, we can send signals, we can do lots of stuff. From there the fascination starts. Then came mini onboard processors. Those were small computers for different tasks that commanded the signals one by one, packed them in different packages and send it to Earth. Further, the discovery of multiprocessors. As we all know, we use mobile phones, computers. We could do n number of tasks. We could use n number of applications. We can open 10 browsers one at a time. That's all because of multiprocessors. So that's what came into satellites as well. After this came FPGA based processing. So initially, when any sensor captures data from space, let's say it's a camera, just like a normal phone camera, once it captures the information, it's just raw frames. But how do you store it? How do you process the signal? How do you keep it in a stack? That is done through the FPGA processors that we have. Then comes the today's savior named cloud computing for space. We all know we have Sci-Hub Copernicus. How many of you have heard of it? Sci-Hub Copernicus? Yes, everyone. What about ISSDC? Not, because that's Indian. See, so ISRO has a platform called ISSDC. You get free data since you are an Indian, so you are eligible for it on a priority basis. Go check it out. And after getting this cloud computations, why satellite vendors tend to go for cloud computing? Why didn't they look for anything else? Why was it important? So cloud computing comes with its own perks. First, it's scalable. I have, let's say, 10 clusters here at SkyServe, 10 clusters here at my office at Calidio, 10 clusters at our office in US, and so on. I can connect all those. I can store as much as I can, and it's on me. I can basically buy the whole Earth. I can buy whole Mars and get it all cloud computing clustered. So that's the kind of scalability that we can do. Second, it's reliable. Yes, me as a satellite vendor, I don't want to take the hectic of storing the data, keeping it, cleaning the computers, keeping the temperature. The organization does everything for me. Third, low maintenance. As I had mentioned, I don't have to change the nodes if it's a faulty node, some current power supply has gone, any computer has caught fire, I have got redundancy as well. Fourth is high security, but for whom? If you own a cloud clustering server, then it's high security for you. Hence comes the question, what about defense activations? What about the engagements that people do for sensitive data through cloud computing? So, defense security, data security is negligible on cloud computing. Why? Because even if Amazon AWS claims that we have the best sort of architects, you don't know. It's a person who is handling all that. And it's been ages since CIA, and not just CIA, all this intelligence agencies around are cracking these people and getting all the information from the domains. So this isn't actually what we can rely on forever for data security. Then comes data dependency. Now let's say I am a satellite vendor, I have my satellites flying in space. I want to store 10,000 images. I stored them in a cloud computer. The storage, my plan has expired. I have to be dependent on the cloud provider. I have to tell them that please raise my plan, please increase the computation storage by X amount, etc. etc. So there is a data dependency which obviously we don't want, that we should be relying on as a satellite vendor. High time for analysis. Now let's say there is a satellite who is responsible for managing disasters. It just manages disasters, let's say floods. It's a SAR based satellite. Still, even if you get the data, it's going to take at least 3 to 4 days for you to reach it for analysis. What about the people? What will they do for 3-4 days? How will you get them on track? How will you get them to the nearest hospitals? That's not practically possible, right? It's a very, very big gap in the space industry that the analysis for satellite data takes lots of time. Directly from downlinking to processing, it's too much. Initially the plan was for satellites that it will give us a direct surveillance. But at that time people didn't thought that communications would become very, very much difficult. Hence comes edge computing, which I'll be talking about. High fetching time, yes, let's say I have 10 millions of data, I want to get nth data from it. It's gonna keep loading, refreshing, retrieving no matter how much map reduce you apply. So it's gonna take a lot of time. So yeah, I mean, it is again a flaw for cloud computing as well. Now let's talk about edge computing. What edge computing brings. So let's say this is my region of interest, as in this is the data that I have initially. This is the data which I get. Now you see this ball being small, whereas this ball being large, coated largely. That means the information that I want from a satellite is, let's say for example, I want to identify a number of buildings in a town. But satellite doesn't just give me buildings in the town, it gives me all the information. I just want a 2 MB of information, that is the masks of the buildings in a city. The satellite will give me 300 GB of information. That is the amount of information that we are getting. That is not my end use case, right? Hence, current satellite companies still have this gap. Now, if you go through timeline, first the satellite captures the data, then it downlinks it to the ground station. Then that downlink data is being processed, then it is given to us as customers or you as researchers. This complete time may vary minimum from 3 days to, let's say, maybe 20 days, because that's the revisit cycle of high resolution satellites if you see for open source. So this is the gap that we have currently for now. Let's talk about edge computing. Image is captured in space. In the space itself, you have sent your algorithms. You have told it, I just want the buildings, I just want the roads, I just want the water bodies, that's it. Don't give me any shit, don't give me any other information. The difference in the interpreted and the region of interest, that is your end goal, is negligible. Why? Because you get exactly what you ask for, not any rubbish. And if you see this curve, this time curve, this change curve is very negligible. That means the information underlying your sensor has not changed. The processing is done over it. So the information change is very negligible. That is because of the accuracy of the hardware that we get in floating point variables. Now for edge computing, what happens is, there's a satellite, you get information on the satellite, suppose it's a camera flying in space, you capture it, you process the information on the camera station itself, that is, you process the information on the satellite onboard itself, you just downlink it to the ground station and then you directly give it to the client or the customer or the researcher. This drops this 20 days of tasks to fractions, that means to minutes. Imagine getting some analysis for, you have to wait for 20 days. Edge computing is giving you it in 30 minutes. How much time is reduced? It's exponential. Now I would want you to think, what could be after that? Seeing this diagram, can anyone maybe support an idea that even further fastens this process? Anyone?
Have the analysis on the satellite itself?
Yes, that's what we are doing. So
without the processing in between, cutting that down.
So processing is done here on the satellite itself, then it's sent to the ground station on our cluster or to my company server, and then it's given to the customers. Well, good going, but little bit of tweaks needed.
Only restricted to the area of interest.
Yes, that's one thing. That's edge computers do. Very good. What else?
Eliminate the ground station itself.
Exactly. So you process information in space. Instead of sending it to the ground station, you can have it encrypted through your quantum encryption algorithms. You can send it directly to the customers. No problem as such. You can have that small cluster in space itself. Imagine your cluster flying in space and directly sending it to the customer. That means me as a customer, I request a certain AOI. I want maps in this building, or sorry, maps in this city. It will just take me 10 minutes to send it to the customer from space. That means from another end of the world, I go to another end of the world, I map it in real time. That's the difference edge computing is bringing. Now, just to give you an idea what edge computers look like, this is an Arctic 7 edge FPGA. FPGAs are nothing but logic gates programmed through VHDL languages. Now, this is a Google Coral Edge TPU. That means if you see your Google Pixel, you will have something like this in your phone. An edge device, as I have told already, is a processor that is present on the sensor itself, integrated with it, that processes it with the sensor as soon as the image is acquired, or as soon as the data is acquired. This is a VPU, Intel Myrit. Now you can see this small piece of shit is doing some crazy calculations with this small amount of magnitude. I mean, this just blows my mind. It's a VPU, it's a vision-based processor, vision processing unit, and Myrit X is a great architecture. You should look into it if you are into computations. You have NVIDIA Jetson Xavier, you have Jetson Nano as well, where SkyServe people have extensively worked on Jetsons, so Rupesh might be the right person to tell you about it. Then we have AMD Xilinx, it's a CPU plus GPU as integrated system. Also you have Iridium Edge, that's for communication, so communicating between different sensors on space. If you have IoT devices, it's gonna work there for sure. Possibilities, I see it as infinite. If you talk about edge in space, there is no limit to it. There is no application that cannot be done from space. Now, let's see what impact edge computer gives to us as humans and to the people around or the nature around. Real-time analysis first. As I had told you, instead of waiting for weeks or something, you can do it in minutes. Even seconds, yes, I am saying it even in seconds. If you have a good downlinking rate, you can maybe within a minute you can classify the whole city and you can downlink that whole information based on your region of interest. If your model size is less than 5 MB, that's the kind of computations you can do on edge. Higher security, there is no partner in between. That's my device, I write the code, that's my kernel, that's my OS, everything is on me. There is no scope of hacking, it's on me. I don't know if Chinese comes in between, takes the communication signals in between and creates some technology like that, but until now nothing has been proven of that sort. Easily upgradable, so it's like, earlier we used to have computers where graphic cards weren't there, right? But we used to rant to our friends, I want a graphic card, I want more RAM. How easy it is, you just open it, you just fix in a slot. That's just an edge computer. It's like a normal device. Obviously you have motherboards, you have a power budget. Related to that you have a wide variety where you can obviously upgrade GPU, CPU core, RAM, etc. Calamity management or disaster management no longer a dream. Now imagine floods being spread across Pakistan. If you had heard last year, and earthquakes in Turkey. People died out of starvation, out of medical emergencies. There was no help. What were satellites doing? We spent billions of dollars worldwide. Still, we could tell the information in 10 days, within a week. Maxar Technologies was the first for Turkey to release the data and make it open source. Still, they took 1 week of time. What were the people doing? How would they rely on this sort of technology? There was nothing for now until edge comes into picture. This is the importance that edge plays in humans' lives, saving lives, whether it be wildfires, rainforest fires, that's very common. You have earthquakes, you have floods, you have droughts, anything, you got it covered. Then comes bandwidth optimization. So now this might be a little technical. So there is one problem in space, that's still the downlinking cost. That means the data that you want to downlink from your satellite to a ground station is very high. Speed is very bad, like very bad. So you don't want your GBs to be downlinking over and over again for months or weeks, right? Either you pay them good cash, they'll do it for you in some time. If you don't pay them good cash, then you're gone. You have to wait for weeks or months to maybe uplink your models or downlink your data. But if you just have the insights, let's say I just have a vector file, it's hardly few MBs, sometimes KBs also if it's a small vector file of different regions. That information can be transmitted very easily. So Edge Computers does this end-to-end optimizations, and it gives you the small vector output as well. Another thing, Edge Computers are power efficient. So let's say you have a computer at your home, whereas you have an edge device. Your computer will consume 100 watts of power, whereas your edge computer is designed in such a way that it will consume only 30 to 50 watts of power. So that's the hardware level optimization that we have done on the power. Supercomputing optimizations you can do on edge, it's very great. I'll show you the results what we have achieved. High impact on human lives, I have told you, can save lots and lots of lives, not just humans, animals, flora, fauna, you got it all covered. Latency reduction, as I had mentioned you, instead of waiting for 15 days, you do it in minutes. Autonomous/AI satellite capabilities. How many of you have seen Mission Impossible Dead Reckoning? Hands up. Very less people. Yeah. So you know that there is an AI that has got the whole world cover, and it's feeding information from satellites as well. But that's the bad AI. We can make satellites smart. We can make satellites to choose, to decide on their own what region to pick from the certain AOI, what algorithm to apply. If I have 5 algorithms for one business use case, what would be the best? Is it worth it for my business use case or not? I just leave it to the satellite is gonna run my whole mission and business. That's the upcoming future that you're gonna have. You don't need anyone to think that whether this area will be covered, will this give me profit or not. Satellite data got it all covered. So that's the future of edge computing as well. Now these are some of the calamities, disasters that happened. This is wildlife fires in Yakutia. So you can see the dates ranging from 6 to 18. It's 12 days if I'm not wrong. I think in this span 1.5 lakh of animals died of grade 2. Grade 2 means deers and all the big animals. So the conservationists or the environmentalists said that if that could have been monitored, we could have brought it down to few thousands. That means less than 5,000. But we did not have that coverage. Hence comes edge. Floods in Pakistan. Very bad situation. This is an Indian satellite. It's published by ISRO, ResourceSat 2. I think this was a 3-month problem. Yes, May to August. Now imagine what people would have done for 3 months. They just drowned, they just starved to death. That happened in Pakistan. We don't want the whole country or the whole world to suffer like that. Similarly, you have earthquakes in Turkey. So if we had an edge satellite, maybe if Argus is launched, then we could have given them the right route optimization within 1 hour. That means earthquake has happened, we could have told the people from one point to another point where they could have gone for hospitals, for resources, for food, for anything. So that could have been done, right? This is the future that's coming through edge. Now we'll talk about some results that we have achieved. Kalidio x SkyServe. Kalidio gave an optimized algorithm edge models which were built by me and my team. So we gave them road network identification. That means the satellite captures pictures and it gives you road networks across the city or any sort of region of interest. Another one was urban water bodies, as it was finding where the water bodies are in a particular area. We had our optimized algorithms, we had our end-to-end pipeline. That means we took the data, we process, we get the output. SkyServe had that engineering pipeline where they have a portal where we could upload the models. We can choose what data to pick on, and then they also had this Jetson device where we could compute all these things. To show you some of the results, one pre-processing thing that we came across was a universal histogram equalization technique that goes on for any satellite data. So as you all know that all the satellites have different specifications of the sensors, right? and this is a very bad thing for your machine learning models. For satellite data of Sentinel-2, DN values may range, for buildings they range from 200 to 255. If you go to something called Satellogic, 1 meter resolution, you might get some different range values. So we build an adaptive histogram equalization based technique. So as you can see, this was the image captured by the satellite. This is the ground truth that we got from Google Earth images. Now you can see the difference in textures that you have in the greeniness, where this is completely bland. After pre-processing, we got these sorts of results, as in we got very close to the ground truth. This was fed to the models and we got good results from it. So you can see the histogram values, they were pretty less, but once after processing we got the histograms right. Now this was an input image that we tested our algorithms on to finding the road networks. Obviously this is a very big tile. I think it was in the range of 20,000 cross 10,000 meter square. So this was the area that is being represented here. We classified it with our optimized algorithms in 20 seconds. That means a city of partially size of Bangalore could be classified for a particular use case within 20 seconds. That's what we did on our end. Now comes Kalidio's treasure. How we as a company came up with state-of-the-art architectures, what things we have achieved. And these comparisons are not just for the geospatial community, but it's across the entire globe. The results which we have got are compared with NVIDIA, AMD, Neptune.ai and other companies as well. First comes, we created an inferencing based pipeline. So inferencing, if people are not into deep learning, inferencing means you feed in an image to a model, machine learning model. It does inferencing, that means it identifies the patterns which you have told it to identify and further generate a classification map. So I feed an input image of let's say Bangalore only, and I want the model to inference the roads from it. So it will inference the roads from it. The current world champ was doing inferencing, whether it be a TensorFlow based model or whether it be a PyTorch based model. It was doing inferencing on a scale of hundreds of seconds. We made an algorithm that is minimum 25 times faster. NVIDIA revealed their results 3 months ago. That was solely on GPU. Neptune.ai revealed a result that was solely on GPU as well. We created a pipeline and an algorithm that works both on CPU and GPU and is 25 times faster than all the algorithms that does inferencing in the world. So this is one of the state-of-the-art architectures we have got for deep learning. Now we also created a GPU based kernel. What it means is, you don't want your CPU to crash in space, you don't want to overload it, right? Your GPU does very minimal work. We came up with a pipeline that the sensor's information is directly captured and stored in a GPU, processed in a GPU, saved in a GPU cache and given it to the hard drive which you have. Further it can be downlinked. So this is what we had created. What people usually do is they first transfer the information through a CPU, then the registers write the code or registers write the information and addresses where the information has to be located. Then it goes towards the GPU and then it doesn't. So we came up with an algorithm and a hardware innovation technique that directly loads the data to GPU and processes it in edge devices. Automated georeferencing. How many people of you know what georeferencing is? Can you raise your hands? Almost everyone, since everyone is from spatial community. Now you don't want your data to be skewed, or you don't want it to be out of maps on the reference base map. We created an algorithm that identifies certain features automatically from the base map. It identifies similar features on the region of interest, from a certain buffer, it maps its coordinate in space, applies transformations in space, and downlinks the data automatically. So how many of you know that we used to georeference using tie points, clicking on AirDAS and stuff, right? Everyone knows. That part is gone. You don't have to do anything. You just have to give a base map. You give your region of interest. The algorithm automatically finds those features, whether it be a lake, building, or any feature. It acts as an anomaly for the algorithm, and it transfers its features and georeferencing coordinates onto it, and it does transformations as well. So showing some results, 3.4 hour was taken for very large area of computations. Let's say, I think we were mapping half of India for a certain use case. We brought it down to 30 seconds, but this was done on a cloud device, AWS if I name it. When we went to Edge, that time automatically got reduced to 2.6 hours because of its hardware capability, because the compute units are aligned much closer to it physically and logically as well. So imagine a thing in your computer takes 2 hours to load and process. That is dropped down to 7 seconds. That means in space, even if you have captured very big information and very large area, even if it was taking 2.6 hours of computation time, we got it covered through our edge device. We can do it in 7 seconds by the supercomputing optimizations that we have. So this was an i7 processor. At that time it was the 3rd fastest in the world. It was giving an accuracy of, a time complexity of 1.02 seconds, whereas on the edge device that we have, it took only 0.5 seconds. Even the fastest CPU on the world, 3rd fastest CPU on the world, if I correct myself, and consuming 4 times more power, still is half time slower. Imagine the potential of edge devices that you have and what magnitude of difference that you can bring. Now let's talk about the future. What can we do? Autonomous satellites, AI satellites, do nothing at all. Even let the satellite decide the business use case based on your resolution and the data it's doing. Satellite got the business covered for you. Quantum computing based edge processing. Now quantum computing again looks like a far-fetched dream, but internally at Calidio we are working on it. We are developing quantum computing based algorithms that kind of not just work on actual quantum computers but on simulated environment that can run on edge as well. Local drones, machines commanded through satellite analytics. Now this is a very important thing. Let's say you have a disaster in a certain area, your satellite identifies that region of interest. Within that region, it commands the drones of the government agency or the organization which you have collaborated with. It specifically tells you what are the hot spots, where the drone has to fly, where it has to go, what particular execution it has to do, and it does everything. So that is what the future looks like. Calamity management, we have talked a lot about this. Inter-satellite communication. Now there is one problem that is still in the space community. Let's say you have a fleet of 10 satellites or 4 satellites. The connectivity or the connection between the satellites for capturing the data is still not there. You send the signals to ground station. The ground station analyzes, processes the trajectory, and then it uplinks it and tells the satellite, okay, once you get your 3rd pass, you capture this data because you have an off-another accuracy of this particular percentage, etc. That can be possible through edge. You are saving very, very large amount of your money if you are doing inter-satellite communications. So yeah, that's it. If anyone has questions, let me know. No questions, I suppose?
Yeah, I have a question.
Yeah.
Thanks, Arya. That's very cool. So I just want to see in terms of actual use case of when you're looking at like researchers like us, how is edge computing data more accessible? Because at the moment what I see is even for us to let's say take like Landsat data or something, I think I'm pretty sure 80% of us still probably go to USGS and download, that archaic method is still being used people are not aware of God,
Right.
they don't know what God is.
Right.
So where do you see edge computing, which is literally bleeding edge or actually getting data to customers or to researchers? When do you see this actually happening in institutions and organizations and colleges where remote sensing and GIS is still being at a nascent stage, let's say,
right,
and not modern enough?
So segregating two parts, customers and researchers both have a different mindset. Segregating those customers, yes, by the end of this year, maybe by SkyServe, by 2025 by Calidio, that's for sure. So edge computers are being built. I mean, we are the first movers in it, that's for sure. But people are racing like anything. People are going crazy. Even on the Pragyan rover you have, right, through Chandrayaan 3, there also you have a small edge computer that drills it, identifies the patterns, takes out the information, does the spectral analysis, and sends the data. That is there, one thing. About researchers, well, everyone would want to pursue their interest in the research, right? Let's say, for example, I worked on South Pole of Mars. I have worked on detection of water ice for that. Now I want a satellite to continuously map water ice, give me the difference in the dielectrics and the backscatter that I get from the SAR data. Now that is my particular problem statement, right? Your might be something different. You want to find volatiles, you want to find serpentine, you want to find something else on Moon, on Mars. For researchers, there should come a collaborative effort from big institutions like we have at MIT, Harvard, Stanford and other Ivy Leagues and big institutions. I think IITs are catching up. They are coming up with collaborative mindsets for a big problem statements as planetary scientists for space that I am aware of. Where edge computing will come into play is, I don't have to wait for the data to come, get it processed, and then I publish my results and contribute to the scientific community. This is the problem we are facing with IIRS data in Chandrayaan 2. So I still work partially with ISRO for this particular mapping of Moon through the minerals all around the globe of Moon. So data is still not there for IIRS. Why? Because it's again saved on a cloud computer. It takes enormous amount of time to fetch a region of interest. Can't do it. If I have an edge device, I'll map the minerals on the fly. I'll map the entire globe of Moon within a week. That's the capability that we can do. But it's been 1 year and we haven't done anything. We haven't reached to a certain benchmark. So that's the kind of gap that can be filled for researchers and communities. Any more questions? Yeah.
What about the scalability?
Scalability.
Like how many satellite you need in order to get live? I mean, it's almost live, right?
So it's more of like, let's say a satellite has a life of 5 years. For 5 years, you can do 10 applications through your satellite. You send your models, you uplink your 10 models. Those 10 models will generate 10 classification maps, correct? These 10 classification maps will be generated through the entire globe. Now you come up with another problem statement, what to do next, right? That is your question, how can we scale the applications? We can uplink the applications or models to the edge computer. That's not a problem. If your uplink speed is good, you can do it in days. So let's say I want to map, let's say potential fishery zones or anything. My model would hardly take 2 days to uplink and I can map the entire globe for potential coastal regions based on the recurring time visit of the satellite. Scalability is not an issue for now. Yeah.
It's one satellite per customer?
No, one satellite not per customer. So rightly pointed. So what you are thinking right now is one application can be present on one edge device, right? That's not the case. You can put, I don't know, maybe hundreds of applications on an edge device. You can update them.
Yeah, that is limited.
Yes, that depends on the data you have. Typically, edge computers right now have 500 GB of storage. One model ranges from, if you are talking about deep learning, it ranges from as small as 2 to 3 MBs. It can go to 100 or 200 MBs with its super resolution or something. So you can do the math based on the models. That is not a problem at all. But yes, every satellite has its limited availability, and computing capabilities are obviously limited. So Edge has some limitations, but that is not restricted to the magnitude of the problems that it is solving at the moment. Yeah.
So you will be finalizing some algorithms and then using it in Edge something, right?
Yes.
Say, for example, doing mineral mapping.
Yes.
Something. So beforehand you need to have some algorithm that works, say 90% or 95% accuracy.
Yes.
But that doesn't mean that it will work for all of the geographical areas and different times.
So that is a problem of the model that we have, the training data that you have provided. That's not the computational lag that you have in Edge. So your problem statement, if I quote it right, is in India I am able to classify types of urban areas. I am classifying LULC maps. I am generating LULC maps, right? In India, I am getting 90% accuracy, whereas if I go to South Africa, it completely goes haywire. That is because of the model that you have. The model should be, I would say, smart enough to do it. Current example of that is super resolution, released by Meta. So what it does is, you have 10 meters of information, you can super resolve it and bring your resolution to 1 meter. So that's the kind of processing synthetically that is being done, and it's giving an accuracy of 95% plus around the globe. So that's a limitation of the models that we need to build, and yes, obviously we as geospatial enthusiasts and researchers, we should develop robust models that work on different geographies. For your solution, what we have on Edge is, let's say I classify the whole globe based on different regions into 10 subdivisions. I have my different thresholds for my model for those 10 different regions. So when my satellite goes into a specific area, it knows what threshold and values to pick, and it classifies based on that. So that can be done.
In case if that model
is failing in space.
Then you need to do
uplinking, yes.
Once again, right?
Yes.
That costs even more.
That costs even more.
Yes, because if you are taking a raw data, you can process it whatever the way you want, because you have a data.
Yeah.
You can try n number of algorithms.
Yes.
On the same raw data. But
Yes.
here, once you try the algorithm, that raw data is gone, and you need to recapture it again.
So what you are essentially saying is, instead of we are not downlinking the raw data, that means we are missing the training data. That is your concern, is right? So if my problem statement is making the model better, then downlinking the data would be the thing that I want to do. So in that case, you are removing the aspect of edge. That means you actually want to downlink the raw data and train your model again. That's an entirely different problem statement.
How do you differentiate these problems? Like we don't know that, because sometimes there can be situations these models will fail. Whatever you said. That
So if you are, I think this can be a more remote sensing based problem. So for solving this, a solution I can give you right now is, I see how my pixels or the histograms follow a trend in different geographies. I have similar resolution data on Earth that is already archived. Correct? I synthetically try to fit that histogram of my raw data, which I already know because I have designed the sensor. I own the sensor. I know what quantum electron flux is going on it. I know what electrons are falling on it. I know how the histogram is being dispersed. I'll synthetically map that histogram to the data that I have on ground, instead of bringing it on the ground. That is what I can do, and I can retrain my model here and then I can uplink it. That is what I can do if my model is failing and you specifically want to use edge for it. Also, one case for this is, I have 100 MB of image. Through edge processing algorithms, I can compress it to 10 MB. I can downlink it and reduce my cost, and I can upsample it again here through the algorithm key that I have, and then I can train my algorithms. So edge again wins here. Any more questions? Maybe we'll take a last one. Alright, thanks. Thank you.
Alright, we'll start in a minute, I guess.
Yeah, we can start.
We can start. Alright, good afternoon everyone. I am Rupesh. I'm working as a senior software engineer at SkyServe. First, I would like to thank my friends here, Parag and Arya, for giving great talk. As Parag has mentioned, one of the geospatial applications, that is the geospatial, how remote sensing helps in the fisheries. And Arya did the preface of how edge computing is very much useful and what are the benefits of it. So my talk would be mostly about making these AI models edge ready. So when we talk about edge computing, we also want to know like how we can make this already existing AI models edge compatible. So yeah, so I will just start. So at SkyServe, we are committed to develop cutting edge technologies that pave the way for widespread adoption of geospatial intelligence. And just a second, sorry. Yeah, we are obsessed on bringing down existing barriers on cost, knowledge and latency so that the geospatial intelligence is accessible and usable across diverse industries. Our innovative solutions that we have built and will be building aim to streamline the incorporation of this geospatial data and analysis, empowering organizations and individuals to make informed decisions within minutes or seconds. So while we started working on the fundamentals of edge computing, we knew that the true consumers of this would be users, subject matter experts, or having operational knowledge on user domains like agriculture, finance, fisheries. So basically the end user who have very much knowledge about these end applications. So although the latest developments in AI and ML have changed the way these geospatial applications are developed, there is still a very know-how and technical barrier, which we also saw in the questions here, on how the subject matter experts, the people who are already building existing AI ML models, and how can you make this more edge compatible, that is, how can you make sure that these models work seamlessly on the edge as well. So we started working on a tool to abstract out the non-essential stuffs and the complicated workflows so that you can seamlessly import your existing AI ML models and make it edge ready. That is, you can be sure that this works on the edge environment on the space as well. So how does this tool help the developers in that context? So we learned from an experience, and as Arya also mentioned, with the several iterations, that one of the major roadblocks that you face while developing for the edge is the edge hardware constraints, which is not easily replicable, or you cannot have a simulated way of testing on how these existing models will behave on an edge environment. So we wanted to, we built a tool wherein you have the similar environments both on the libraries versions that you have as well as the hardware requirements, that is, you have the limits on the CPU, the RAM and other stuffs. Hence, we built this tool that allows you to seamlessly submit your already existing AI or ML models, and we would be validating and testing it on our end on the edge hardware to make sure that these models are edge ready. So I will just go through the walkthrough of the tool and meanwhile also tell you the nuisances that we have while building these AI models for the edge. So yeah, I will just start by adding the model. So in most scenarios we have plenty of AI ML developers everywhere. So the issue is not with the ability or knowledge to build this artificial intelligence or machine learning models that fits one business use cases. But when it's done on the edge, you have several constraints, whether it will work on that images or not, and whether it will work on that hardware. In many cases, the architecture itself is different. So the same library and same algorithms that works on your computer might not work on the edge. So we will start, so in the tool we start by submitting the details of an already existing model that you have. So I'll just write some of the key terms, just a second. So first one is a model name. Model name is nothing but a unique identifier that you might be giving for your model that you already have. And then this could be based on the use case or what it does. Like in case when Arya mentioned in the road network case, he can mention road network and other stuff. So I will just do a demo with a multi-class segmentation model. So what this model does is, just a second. Yeah, so what this model does is nothing but classify based on the given image what class or object, what classes of in the given classes that we will be providing later on, what classes does this image fall into. So you can just put your model name. Then model description is nothing but a brief description about what your model does. This is not only helpful to you but also to the end user or other people who would be using your model if you wish to do so. Just a second. Alright, and then you have model type. So if you are from the machine learning or AI background, you must be knowing that you can either have a deep learning based model or one of the classical models. Classical models could be something like computer vision based models which use contour detection or any other classical algorithms that you might be having, like regression or something like that. Or you can also have a deep learning based model trained on various data and various data to give output based on that. So in my case, the model which I am testing on is a deep learning based model, and I will select that. And visibility is nothing but it controls who can do inferencing on the model. Inferencing is nothing but when something goes to the model and does the model gives output. So that is the inferencing part. So who can do inferencing? As a developer, you might be wanting to test yourself. So you can keep it as private. And in case if you want someone else to test it out, you can give that option as well. So I'll just go to the next phase. So these are nothing, so as I mentioned, these are for the existing models. So your existing models might be residing in some of the existing repository structure like GitHub, Bitbucket or any other GitLab, etc. So what you can do is just place in the URLs that you have for where your model resides. And what we will do is we will use this to pull the models from there and start testing it on our edge devices. Just a second, I'll just fill in the details, I guess. So model repository URL is nothing but you have the model repository URL. Model path is the path in your model repository where your deep learning model resides. So it could be anywhere in the system, but we have mentioned some guidelines on a documentation such that even your existing or your subsequent models follows the same pattern, so that it will be useful for you and on our side to debug and trace it effectively. So just mention that as well. And last is nothing but the authorization key. So these models we assume are mostly proprietary or are based for some internal testing and some commercial applications as well. So your model repository most likely would be a private one. So authorization key is nothing but GitHub or Bitbucket repository key, which will enable us to read the contents of the file. So I'll just place it. Just a second. Yeah, so model inputs. So all the models will have several inputs on it, and this briefly we will be asking in this tool. You would be briefly mentioning what your model inputs are. As a creator of the model yourself, you will be very clear on what your model expects as an input and what it expects as an output, which will be controlled later. So one is the configurable parameter. So any runtime environment variables that your model takes in, that is while running the model, you have made the model in such a case that it works for certain values. Now you want to tweak some algorithm on the fly. You have to tweak some parameters that controls the output that the model is giving. So in such cases, you can mention that in the configurable parameters that you have mentioned, which in terms, if I go technical, in Python case, you can use rparse arguments and stuff like that to parse these command line arguments that you would be providing to your model. So I will just give one. So this model I'm just giving a threshold low parameter which actually controls the contour detection on this model. But in your case, and if I may, like for the urban water body, like the detection of water bodies, if it is there, you can control what is the largest size of the lake you want to detect and what is the minimum size of the lake you want to detect. So those are the configurable parameters that you can mention over here. Just fill in the other details. Other details are like the data type of it and the values and one of the default values if you wish to add so. Just a second. Then model input. So as we are on the geospatial community and we are working with images, we know that images have bands. Bands are nothing but the way the images have each band, that is red, blue and other colors, how are they organized in the bands, and many often based on the sensors that we have and the operators that are present, this band order could be different. So you could be having a RGB image or BGR image and stuff like that. So for input bands, the way you have trained these models on which type of images you have trained these models on. Suppose you are training these models on NIR band and followed by RGB or RGB NIR. So you just have to mention that band order, and we will take the we will make sure that the model, when it runs on the edge device, whichever format the sensor gives us, whether it's RGB, BGR or any other format, we'll make sure that but your model gets the inputs in the same order. So we have a utility on our end where we will do the pre-processing and we will feed the same input to your model. So I'll just select this one is just classic red, green, blue. I'll just select that. So input product type. So what is input? So we at SkyServe offer 3 different kinds of input images that can go inside to the model. So as we mentioned, this is all about edge computing. So when a sensor takes the image, it's a very raw image. But the ones you are training on, when it is on the ground, it's not actually a raw image, it's a sort of georeferenced images. So georeferenced images are like you do some haze correction, like the clouds are removed in some manner, the clouds are removed and then you do the georeferencing, that is you put those have latitude and longitude information as well. But while it's working on a sensor, you can actually have various types of products that you want. So radiometrically corrected scene and haze compensated. So radiometrically corrected is nothing but any kind of sensor deformalities that we have on the image due to the sensor itself. We remove it over here and we have that as an image. Second one is haze compensated and last one is georeferenced. Georeferenced you might be using in case you are doing some tiling methodology or using GDAL for any kind of location based information directly on the edge itself. So you might need georeferenced images. In this case it's just a classification, it doesn't require a georeferencing scene, so I will just put that haze compensated. The last part which you can actually get as an input is a cloud mask. So we have 3 different of data type masks that we provide. One is cloud mask, cloud shadow and a no data value mask. So what does so this cloud mask will tell you wherever the clouds are there on the image. So this will be provided as separate files to your model. Again, you don't have to worry about it. We will do the pre-processing on our end to make sure that you get this file separately for your model. So you can use this mask values to do either pre-processing or post-processing on your end. Many cases, like if you're detecting something on the ground, even building or trees, clouds would be there and those clouds will hinder the results of what you're getting on the model output. So in those cases you might want to overlap your result with the cloud mask to see what are the outliers in your case and remove those results which are not relevant. So that there you can have this use case. So I'll just go next. So finally model output. So model output is nothing but as a developer, normal developer, we write code and we define how our output should be structured or what is the name of the output. So that part, so this is nothing but you're just mentioning what will be the name of the output when your model runs. Since the developers write the code themselves, they can have different naming conventions that they follow. And we didn't want to standardize on that, so we mentioned that you can put any name you want, but just this form just lets us know that what is the name that you have used, and this will be used internally to identify whether the model worked correctly or not. In many cases, we have seen that the model works perfectly on the ground, but on the edge something happens and the model output doesn't come out. So how do we make sure that the model behaves as expected? So for that, we need the output part. So I'll just put, and then you have different types of output types. So we studied several machine learning AI models, and we came across that most of these models could be classified based on these 4 output types that they give. First one is just an image. Image is nothing but your model or a geospatial applications takes in an image as an input and gives an image as an output, which could be like a pan sharpening thing or a histogram equalization you're doing, which is just an enhancement of the original image, and you get the original image with some enhancement. Second is a segmentation. Segmentation types are nothing but like you can have cloud segmentation models, which tells you, which is nothing but a binary mask, which tells you whether the clouds are there or not. You can have zeros for the no cloud, 1 for the clouds. And object classification and detection, both are more or less same. The difference between is like in classification, you will have in classification you will you have to classify. It will classify the entire image. It will detect and classify. In case of object classification, that if you have a very big image, it can detect and classify where the water bodies are, where the trees are, where the buildings are, and you will get a list of bounding boxes and other stuff in the ground, because that is what we use for in a daily basis. Like when the image is there and you're doing some urban planning or some stuff, you want to know where the buildings are so that you can construct the road about it or other stuff. So I'll just put the details for this model. This has, just a second. This one is object classification. Detection geometry type is nothing but bounding box or point. So in case of geospatial industries, we have either a point XY value, or you can have a bounding box altogether for a bigger classifying model like building, detection of building, lakes or other stuff. So I will just put in, okay, yeah, so there are several inputs to it. So once, in case of classification models, you will have a different classes that you might have defined on your side, on your end. And this could be like, what does the pixel value or class value 0 means in your code? So in most cases, the developers have this text file or a CSV or JSON file where they have these mappings of what each class represents, what is the value 1 represent. So since we are testing it, we do not know what those actually mean. So in this tool, you just have to mention what these means, so that when we are getting the output from the edge, we can configure it accordingly and show you that way on the dashboard on the metric side, that okay, these are the class values that it has come from. Or else if this is not present, then you will have to manually map it on your end once you have the output. So there are a lot of outputs. I will just, once you click on save, what happens, I will tell you the flow what happens once you save. Once you save, what happens is we run through a list of several validation algorithms that we have come across in our development of last 5 to 6 months, that we have seen that okay, these are the things that need to be tested for the edge compatibility. So it runs through the series of that task, and it will tell you whether your model was successful or not. In case it is not successful, it will also show you the proper error logs to tell you it will tell you that where is the error, on which line, or what did you miss during this, or it could be intrinsically to your model itself. In case of any runtime error also, we tell you what the error was, so that you can go back and debug. So I will just show you one of all these edge cases. So once you submit your model, you will have all your models listed over here on my models page. So we also, as I mentioned in the beginning, we abstracted out the non-essential stuff that developers or other people are keeping. So versioning is one of the major headache that we have seen that happens. You have to keep track of the versioning system. So how do you version your models? And how does the model work when you submit a one more model or you're working on an iterative way? Because when you're working on these models, many a times it will happen that the output is not what you were expecting. So you will submit, change your code, submit it back. So we have took care of the automated versioning systems and displaying of these model results and stuff. So I will just show you what happens if the validation, or as I mentioned, validation fails. So in case the validation fails, you will see a certain log of this kind. This is one of the demo logs that actual logs, but yeah, the contents might change. So in this one, it is showing that the expected for output file name doesn't match. So what happens is, as I mentioned, once you submit your in the my submit model, once you submit all the input fields, here you will see list of what you have submitted so far, and here you will also see the images and and all the different types of output details that you mentioned. Here if you see in this one, just a second, I'm not sure if it's visible or not, but here I mentioned a wrong output name earlier. That is, I gave the output name as out1 while filling it. So it was trying to find for a given input image of input.div, it was trying to find an output image of input-out1.div, which was obviously not found during the validation step. Hence the error that we are seeing over here, that there is a missing file over there. So how do you rectify it? You can rectify it using directly the resubmit phase, where you don't have to fill in back all the details that you have already filled. You just go back here, just change the value again and just save it. Once you save and submit, it will again go through the iterative flow and check all the details again. If it is successful, then it will come back, just a second. Yeah, it will come back with a saying validation was successful. Now, after this comes the interesting part, which one of the folks also mentioned. How do you check whether this model works on the images that you have from the sensor? And how do you make sure that these models that have been trained on different images works on any other sensors, any other sensor with different configuration? So once you have this basic validation done, where you test the basic fields, you have this option of start testing. So when you do start testing, you'll see a list of images, and this would be sensor and mission specific. By mission we mean the satellite that we are flying on, and based on that you will have the sensor configurations and the image quality as well. So we'll show you the list of all the images that the sensors already have. Based on that, and the resolution and all other characteristic will also match of what is of the sensor that this model will fly with. So till now you trained your model on the images that you got from internet or other public data sets. But now it's the time to check whether this model works fine when you have the image from the sensors. How does it work when you run it on an image which is for the sensor? So here you can select any of the image, and then we also, based on the license agreement that we have from the operator, that satellite operator that we would be flying with, you might have the option to download the image as well. This could be really useful if you want to see if there is any kind of pre-processing that you would need on these images or on your model end, on the model side of the code. Like if you go back to the previous talk, like Arya mentioned, one of the equalization values which are different sensor to sensor. So we will give the statistics as well, but statistics you might not be able to clearly identify that issue just with the help of statistics. In some cases you might want to download the images, run it through a geospatial software like Snap or something, and see what are the range values that you are getting for each of these band values. So once you do start testing, what it will do is it will start your model again. It will try to run your model from this sensor image that you are given. Now we go through an iterative fashion where we change each components one by one. In first we just check the basic validation, second we check whether it works fine with the sensor images. The last stage is where we will check on the edge hardware itself directly, which will be flying on. So it will take some time, I guess. I will just show you one existing one where we have the results since it's directly running on the background itself. So once the testing is successful, if the testing is successful, you will see if you go to the check testing result, you will see the list of results that this model has given. And here you will see a list of images that was fed into the model. In many cases this would be simply the model. Just a second, I'll just move this. I hope it goes just a second. Yeah. So this is the image that went inside. In this case it was just the RGB, so the image looks exactly what it was in the preview. But this goes through the pre-processing steps. That means if you change the band order, which I talked about in the earlier, RGB to NIR or something, this color will definitely change over here. But that is the representation of what went inside, what went into the model. Just a second. And if you want, you can download that actual file, which has all the pre-processing that we did on our end from here. And then you have this model outputs. So in this scenario, it had two outputs. One of them was an image which had some basic contour detection. Second was just a classification of the entire image, broadly classifying what feature it detected. So in this case, you can download the analytical file directly from here, the original analytical file, which you can do further processing. Like it's a TIFF file, if you see, it's a TIFF file, and if you download it, you can open it in your software to check how it looks like and stuff. And if you want, you can just download the preview and just a second. And you can see how it looks like. So in these scenarios, you will be able to see the results directly and make informed decisions on this. And if you want, you can go back to your coding, go back to your drawing boards, change something based on the results that you see here, because these are the actual results that would be visible on the edge hardware as well. And yeah, and any kind of notifications that you would be having will be notified here whenever it's successful or something. It will just notify you over the notification on the tool and as well as mail, because always you might not have the tool open, so yes, you will have on the mail as well. And in case you have any related, all the details of each of these nitty-gritty and all the detailed documentation regarding the sensor specs, regarding the developer portal, the APIs, and all that goes inside will be visible in the documentation. So that is how we at SkyServe are planning to make the normal AI models edge ready in a seamless manner, because we spent months trying to just make the models acceptable by the hardware, and it seems like it's an easy task, but when you start installing, you will see one of the libraries is not getting installed, and even a version downgrade, which doesn't seem very crucial in case of normal development on computers, can have severe impact on the output results that you're getting on the edge. So in such scenarios, you can just simply use the tool and just submit it, and it will make your models, you will know that models are edge ready or not. Yes, so that's it from my side on the tool that we have. And we will be, I think we will be doing a closed beta soon, so anyone interested can actually sign up on the website that we have. And yes, any questions?
You want to show the website where it is?
Yeah, sorry. Just a second. Yeah, so the official website that we have, that enabling insights as service from the edge. In the bottom, if you go to here, get early access, you can just fill the basic form, and we will just let you know. We are doing some final testing on our side to make sure on the security and other stuff and other little bit details. Once it's live, we will let you know, and we'll just send you the email invites. So we're doing the closed beta first, and then followed by the open beta. Yeah. So any questions on regarding edge computing, regarding the tool, or anything else in general regarding this? Yes.
Other than the software compatibility, the version compatibility, what else do you mean by edge compatibility from the model itself?
Model itself means, when you're developing a model, you will be listing out certain libraries, right? Like if it's a TensorFlow based model, you will be mentioning TensorFlow version on that one, and it will work on that only. Like certain functions might be there in certain versions, but not present in the older one. But due to the constraint that we have on the edge, you cannot install everything on the edge. So once we finalize the hardware first, and once we finalize the hardware, we finalize the environment that it would be flying in. So based on that, we might not be able to support all the libraries. Even if the library is supported, maybe the version might not be supported. As we have seen in our step, because the architecture itself is different. Some of the libraries are written in such a way that it works on the native Intel-based computers, ARM-based processor, AMD-based processor. But once it goes to the ARM-based processor, it just goes haywire. It doesn't install. You will see a lot of. One of the popular example is Raster.io. If you use Raster.io, which is a great tool for working with multiple bands, which is in the scenario of edge computing, you would be working with more than 4 bands. So usually. So installing Raster.io on an edge device that we were working on was a very challenging task. It had a lot of compatibility issues and other stuff. So those I mean by software compatibility. Alright, any other question regarding edge computing or?
Any more questions?
See, once these models are finalized here on the edge, like once it goes through all the pipeline, it's basically is edge ready. So initially what will happen is we'll let the developers know that your models are edge ready. That means it is ready to fly in space. It will work in space as because we did extensive testing. So to initially send that model to space, yeah, some charge might be applied and some license agreements and stuff. But based on the usage, developer would be incentivized. So the initial phase where you are submitting the model to the space might be charged on you, but any inferences being done or the usage of your model, which is like if you're doing on your private, then obviously you're using it for commercial purpose somewhere else, and if not, you're doing it for opening it for public, then you would be getting the benefit of the model that you made, because others are using, you will be incentivized based on that. So it's a win-win condition for both the researchers who are actually using these models and developers who made these models. Alright, that's it. Okay, alright, thank you everyone.
Thank you for the presentation, it was really good. Looking forward for the launch and then the future things.
Hey everyone, so I hope
you enjoyed the sessions from the speakers. So at the end of this, we just want to thank everybody, first of all the attendees who turned up here, and we have a small token of appreciation for the speakers as well as the organizers. So I would request Vinay and Vishesh both to come forward and maybe hand over the token of appreciation. So I would like to call upon Chirag firstly Parag, sorry, my bad. Parag
We can have it together later on with all.
Once the...
Okay, let's take it.
Yeah, next I would like to call upon Arya. Yeah, so since Rupesh is our guy, so we need to point in the office. So next I would like to call upon Santhosh. Amruth, please. So thank you, Amruth and Santhosh, for this.
Samosas were enough, I think. I think this is a lot. Thank you guys.
Okay, so this is also for another guy from your team, that is Aman, who is not here, who did a lot of hard work for this particular event. So thank you guys. So I would like to hand over the mic to Vishesh right now for the closing notes.
Sure. Can you hear me? Okay, I think we are first of all very overwhelmed, surprised by just the turnout. I think there's growing interest in the geospatial field. As SkyServe, it was a great opportunity for us to host this. I think we had a great talk by Parag about how geospatial industry is affecting fisheries. Obviously, Arya, who we work with very closely, we are flying some of the models that will be going in the first SkyServe mission. So great talk. And finally, Rupesh covering our product. This was a closed beta demo. So I would just say that I'm pretty sure it might have triggered some ideas that, okay, you might be working as a solopreneur or a developer who got a great idea, let's say, for making a model, a GeoAI model, for example. And if you want to really use the product and fly with us, and if you feel that there's business potential as well, you definitely come and reach us at partner@skyserve.ai. We have some cards available for that, and it's important that we work together, so we are more than happy to guide you through this process. We have mentioned that these models are going to be edge ready, so this is not a straightforward task that you just submit a model. It may take some time. We have seen that it takes some hard work, some tears as well. But when it gets done, I think the technology demo is well worth it. We're going to fly multiple missions coming 6 months to 9 months timeline. We are just more than excited to have a host of models. So these edge computing devices have enough storage that we could go for multiple models from multiple folks. And it's also a great opportunity for us for getting the feedback on this portal as well. So once again, thank you all for coming, and we hope to see you again in the next LTS as well. Thanks.
Okay, thank you guys. Before closing, I would like to thank SkyServe for hosting us. Thanks for the samosas and the momotos. It was really great to be here. I want to invite Amruth introducing an InGARSS, which is going to be happening in December. So we will, after that introduction, we will have the official close.
InGARSS.org.
Okay, thanks everybody. So a few of us here, I mean the organizers for Let's Talk Spatial are also part of the IEEE GRSS Bangalore section's executive committee. So the four of us, me, Santhosh, Diyaku and Aman, as well as Sai Kiran here somewhere, I see, yeah, there is. So he's also part of the executive committee. So InGARSS in association, I mean the Bangalore session in association with IEEE, the whole international organization, we are having the first physical conference in India after I think ever for the first time. We always had it online before. And it's going to happen at the International Institute for Information Technology, IIIT Bangalore, near Whitefield in December 10 to 13th of end of this year. And we are inviting folks to contribute in terms of publications or presentations and things like that. It's a huge set of domain. So just go to the website. You can actually see all the general calls. You can see who are the members of the committee, all the calls that are actually out right now. And I think next month, August 15th is the deadline for research paper publication. So if you have any sort of research that you're working on and looking at edge computing stuff, I think it's going to be one of the most novel stuff that's going to come into InGARSS if you all are able to, if you want to submit something. So please, I would request all the big shots here have done a lot of work on this. It's really cool stuff. It would be amazing to have this on a platform like InGARSS. It's like a win-win situation, like one of you said. And we also have a lot of tutorials and actual industry speakers coming to the event as well. So just take a look at the website, just go through it, just understand what's happening. There are email contacts for all of us towards the bottom. And also we are offering, or actually we are asking for sponsorships. If any one of you have connects in the industry or the industry themselves would like to be a sponsor for the conference, there are different levels of sponsorships. You could be maybe a diamond sponsor if you really feel wealthy enough, but we have it from a base lane of like around 75,000 all the way up till 5 lakhs. So, and then based on the contribution of your sponsorship, there will be different sets of outreach and stuff put on the website about your company and all of those things. So, sponsorship would be great. As of right now, we have one from IIIT Bangalore, but we also have partnerships. So, you can reach out to the committee members if you would like to be a partner of a specific kind. So, right now we have knowledge partners and then technology partners. And then you can see IEEE Bangalore and the Let's Talk Spatial, they are the technology partners for the conference. But you can also be knowledge partners based on what sort of interaction you do like with the conference attendees. But yeah, so this is just basically an open call to check out our social media pages for the website, for the conference. We have a LinkedIn page and a Twitter page as well. Follow them for updates all the time. We'll keep it running. We want to touch a couple of hundred followers there. Sometime maybe Twitter we don't have as much, but yeah, that's another thing. But yeah, towards the end, if you see, there are very specific community events. This is kind of new. This only happens in very few conferences, maybe not too much in India, but we have something very specific for diversity, especially for women in engineering. So take that as you will. I think we need to put that out as much as possible. Towards the bottom, you have diversity, equity and inclusion sessions. Very specific sessions based only on that theme. It's very interesting to see. And then for young professionals. So all of us young scientists, researchers, developers, please get into this. I think it's a good opportunity for all of us here in the room to sort of outreach into this mechanism. But yeah, I think I just wanted to say that we have this out there. Deadlines are fast approaching, so if you have something to put up, it's good to start now. Okay.
But yeah, I think that we can close the session unless the SkyServe team has something specific to say. A photo? Okay. So yeah, I think we can all arrange wherever they say to arrange. I'm not sure here. Alright. But yeah, that's the close for the session. A photo and then chit chat, talk, and then disperse. Yeah, thank you.